In this video, I'm going to walk you through the steps of conducting a 2 by k within subjects factorial Anova. So there are two independent variables in this design, and one of the independent variables has a lot more than just two levels. So specifically, we have a research design where individuals rated the desirability of prospective partners on the basis of their IQ, and there are several percentiles associated with the ratings. So they rated someone at the first percentile of IQ, 10th, 25th, 50th, 75th, 90th, and 99. So that's 1, 2, 3, 4, 5, 6, 7 levels in that within subjects factor, which is IQ level, which is their IQ. And then there's another independent variable, which is what type of relationship are they considering? Is it just a sexual relationship, or is it more of a long-term relationship where, marriage and children? So in that case, it's called partner. So we got sex only and partnership. So it's a 2 by 7 repeated measures factorial design. So to analyze these data, you would do exactly the same thing that you would for a 2 by 2 factorial within subjects Anova. Go into Analyze, General Linear Model, Repeated Measures. And the first factor is going to be called relationship type, which there are two types. So type either a sexual relationship or more of a partnership. Click Add. And the other one is going to be IQ level. There are 7 IQ levels. 7. So we got type of relationship, independent variable 1, and IQ level, independent variable 2. Click Define. And now you need to enter the variables into the within subjects variables box in such a way that it's consistent with the variables in the parentheses. So we got relationship type is 1 or 2, sexual relationship or partnership 1, 2, and then we got the IQ levels 1, 2, 3, 4, 5, 6, 7. So it's actually lining up perfectly with the variables in the data file. Sometimes that won't be the case, and so you kind of have to put one variable there, and then you got to choose this one here. Could just be flipped, and then you got to do back and forth. Ideally, you'd be able to set up your design so that you just have to throw your variables in quite easily like this and put them in. There's no between subjects factor in this design. It's purely within subjects. So we click on Options, and we want Descriptives, Effect Size. We don't really need anything else for this analysis. Click Continue. And we click on Estimated Marginal Means. If you have version SPSS 25 and above, you should see this button. If you don't, Estimated Marginal Means would be behind another button. So click on Estimated Marginal Means and put all 3 into here, Display Means for. Do you want to compare the main effects? Well, you could. It might be relevant particularly to the IQ level because there are 7 levels there, and if I wanted to do some sort of Bonferroni correction or adjustment with respect to evaluating the main effect of IQ level. But as I write in a textbook, I use a more powerful approach to evaluate IQ level with more of a trend analysis type of approach. So click on Continue and click on Plots, and you have to decide which variable you want on which axis. And in this case, I thought it made the most sense to put IQ on the horizontal axis. It's usually best to put the variable with the largest number of levels on the horizontal axis, and then the one with fewer as separate lines. So in this case, relationship type has 2 levels, and I put it in a separate lines box. Click Add. Now the default is line chart, which is what you'd want for a within subjects design. You definitely don't want a bar chart. You have the option of including error bars if you like with 95% confidence intervals. These are not going to be adjusted for the within subjects factor. They're just going to be the ordinary unadjusted error bars. I don't really want it for this study because I find it makes the chart too busy, so I'm going to leave those out. But you could include them if you wanted to, or a reviewer insisted on including them. Click Continue, and that should produce everything I need. Click OK. So here's the design of the study reported in the first table. I'm just going to stretch this out a bit to make it viewable. So we have Measure 1, Type 1, which is a sexual relationship. Type 1, and Type 2 is more of a partnership. So those are the 2 levels associated with the relationship type independent variable, and then we've got IQ level 1 through 7, which corresponds to percentile IQ level 1, 10, 25, 50, 75, 90, 99. Then we have the descriptive statistics, which are the means and standard deviations associated with each variable included in the data file. So this is literally these means and standard deviations. And that would be potentially valuable to look at in order to evaluate the interaction, for example. This table does not include the main effects for relationship type, and it also doesn't include the main effects for IQ level. Those are going to be reported lower in the output in the estimated marginal mean section. Multivariate tests table you can ignore. Test of sphericity. For relationship type, there is no test because there are only 2 levels there. And then for IQ level, we do have a statistically significant sphericity test. Therefore, the assumption of sphericity has been violated via Mauchly's W, and we should focus on the Hunefeld adjustment. So here's the Hunefeld value. It's epsilon. People might call this epsilon. And that is going to be used to help adjust the results in order to render them interpretable. The test of sphericity for the type by IQ level interaction is also significant, so I have to consult the Hunefeld adjusted results. Here is the test of within subjects effects. So the relationship type, partnership versus sexual relationship only, is statistically significant, 23.418, p less than 0.001, and partial eta squared equal to 0.058. So I could suggest that 5.8% of the variability in desirability ratings is accounted for, or was accounted for, by relationship type, controlling for or excluding the covariance across conditions. And that's with 1 and 381 degrees of freedom that this F value is statistically significant. Now, the means associated with this analysis, it's comparing 2 means. Sexual relationship collapsed across all 7 IQ levels, and partnership collapsed across all IQ levels. And that mean, or those 2 means, are here. So relationship type 1, which is, you have to go all the way up here to find out, relationship type 1, sexual relationship. Relationship type 1, sexual relationship, 3.696, and then partnership, 3.59. So on average, when you exclude consideration for the various IQ levels, you just collapse them. People rated the desirability of a prospective sexual partner a little bit higher than an overall partner for marriage and children, etc. So that is what this is telling you right here. This F value of 23.48 significant is telling me that these 2 means are significantly different from each other. Now, I don't know if I can interpret the main effect because there is a statistically significant interaction, so I'll get to that in a minute. IQ level is also statistically significant. Now I have to consult the Hunefeld adjusted results. So with 1.71 degrees of freedom in the numerator and 652.00 degrees of freedom in the denominator, Hunefeld adjusted, the F value of 410.856 is statistically significant, and the partial eta squared is equal to 0.519, which suggests that IQ level is accounting for nearly 52% of the variability in desirability ratings, controlling for the effects of the correlation across the desirability ratings. And the means for this main effect of IQ level is reported down here in the estimated marginal means, and here they are. Collapsed across relationship type, partnership and sexual relationship, collapsing those, we get a mean of 2.318. And then at the first percentile of IQ, and then we have the second percentile, which corresponds to the 10th, and it keeps going up, 25th, 50th, 75th, etc. We can see that these means are not all equal to each other across the 7 levels of percentile IQ. They are not equal to each other on the basis of this F value 410.86, and it's statistically significant. But again, there's a significant interaction, so I don't know if I can interpret this main effect or not. And the interaction, Hunefeld, with 3.736 in the numerator degrees of freedom and 1,423.30 degrees of freedom in the denominator. Note that Hunefeld adjustment causes the degrees of freedom to have a decimal place. That's different than the sphericity assumed. Sphericity assumed is always whole numbers. These are all decimal placed. That is the nature of the adjustment. So that is Hunfeld 41.558 F value. F is statistically significant with 0.098 effect size, suggesting that 9.8% of the variance in the desirability ratings was accounted for by the interaction, controlling for the positive correlations across the conditions, as well as extricating the effects due to the main effects. So the omnibus main effects were all statistically significant, rejected the null hypothesis of equal means for relationship type, rejected the null hypothesis of IQ level yielding the same desirability levels. They're not equal, they actually increase, they start going up. So as the prospective partner is more intelligent, their desirability increases. There's a little bit of a dip here though. That might actually be statistically significant, but we have an interaction to consider, so we're not sure if we can interpret this drop yet. It might just be for the sexual relationship level, or it might be for just the partnership. I don't know. We can find out though if we look at this chart. And the chart actually suggests that the means drop from the 90th to the 99th percentile. The desirability drops for both partnership and sexual relationship. So this is the red line, number 2. You have to go back up. What is that? Is that a partnership? And we have relationship type 2 is partnership. Yep, partnership. So here is partnership going down a bit, and sexual relationship attractability also going down. I don't know if these are both statistically significant, and that would be something to look at in further analyses. Now, what I suggested in the textbook, in order to decompose the significant interaction, you have to do a series of smaller 2x2 factorial repeated measures Anovas. And I did that, and I obtained the following results. So this is me doing a series of 2x2 factorial repeated measures Anovas, comparing just the first percentile of IQ and the 10th percentile, and I got a non-significant interaction result, p equal 0.167. So let's actually look at that. I have to redo it from scratch. I have to change this to 2. I'm only looking at 2 levels now. Percentile IQ level 1 and 10. Okay, so that's changed to IQ level 2 levels. Click define, and I want to throw some of this out. Let me just start from scratch. So I want the smarter sex percentile 1 and smarter sex percentile 10. And now I want partner 1 and partner 10. And I'm going to evaluate whether there's an interaction taking place in these data. So what I'm looking at here is this comparison here. Is there a significant interaction going on there? The omnibus interaction suggests there's something going on here to suggest an interaction. I mean, obviously the means are not increasing exactly the same way. In fact, there's even a crisscross over here. So there is an interaction. But is there one over here? Does the level of IQ impact desirability in the same way for both partner attraction and sexual attraction? The answer is no. Based on this, the answer is no. P equal 0.167 with a partial eta squared of 0.005. So let me just do that analysis here. So I did a 2x2, and here is the interaction analysis. I got an F of 1.919 and a p-value of 0.167 and a partial eta squared of 0.005. And here is, that's what I'm reporting here, 0.167 for that 2x2, which is right here, type by IQ level, 2x2, not significant. So there is no interaction going on at this level. And then I just kept doing it. I kept going here, and then I compared that, then I compared that, then I compared this, and that is where the interaction starts happening. So if you keep doing those 2x2s, you will find that eventually you hit significance once you compare the 25th and the 50th percentile. So that's going from here to here. You can see that this increase is not as sharp as that increase. So for partner attraction, it really increases much more substantially than it does for sexual attraction. Sexual attraction is still going up quite a bit, but it goes up even more for partner attraction. So how did I do that? Well, I literally just did another 2x2. analyze, general linear model, repeat, still 2 by 2, throw these variables out, and I'm interested only in the 25th and 50th percentiles, and then I'm going to get a significant result here. The interaction is going to be statistically significant. So here's the test of within subjects effects, and the type by IQ level 8.962, p equal 0.003, and 0.023 effect size. That's where I've got this. The effect size is 0.023, p equal 0.003. Now for the end of the tail here, is the attractiveness of IQ dropping from the 90th to the 99th percentile in a manner that is consistent with an interaction? The answer is no. When I analyzed that and I included only the 90th and 99th percentile, I got a p-value of 0.064, wasn't significant, and a partial eta squared of 0.009. So I could say that desirability in a prospective partner decreases from the 90th to the 99th percentile for both a sexual only relationship or a partnership. They're both going down, and it's not going down at a differential magnitude. But there is also an interaction here. Obviously, these lines are crossing. So basically what's happening in plain language is that IQ has an impact on desirability much more substantially for partnerships than it does for sexual attraction, because when somebody is relatively really dull, the rating of desirability is lower. But as you increase the IQ, it really increases sharply, so much so that by the time you get to the 90 and 99th percentile, it's actually flipped. Now this one for partner is actually higher than sexual attraction. So that is one way to describe the interaction in layperson terms, and you can help support that interpretation on the basis of a series of contiguous 2 by 2 within subjects factorial Anovas, like I've done 3 of them here, or 2 or 3 of them in this example. So the last thing I'm going to talk about in this video is interpreting the nonlinear effect that's going on in these data. I would say it's happening for both partner attraction and sexual attraction, that it's not a linear increase, is it? It's not just a straight line. It's got basically 2 bends in the pattern here, and it's consistent with a cubic effect. And SPSS tests this automatically for you in a within subjects factorial design that has more than 2 levels. And in this case here, you can see that for IQ level, the linear effect is statistically significant, but so is the quadratic and cubic. And although the order 4 effect is statistically significant, I wouldn't go so far as to interpret it. I would restrict the interpretation to the cubic effect. It's the biggest partial eta squared after the linear effect, and I would suggest on the basis of these results that there is an upward sloping trend in the means with respect to the desirability of a prospective partner on the basis of their IQ, but it's not linear. It kind of goes up, and then it goes up steeply, and then it kind of comes down again. So it goes up steeply and then comes down again, and that's consistent with a cubic effect, and I would support that interpretation on the basis of these results here. This F value 246.563 with 1 and 381 degrees of freedom, p less than 0.001, and partial eta squared 0.393. Now there's still a lot of simple main effect analyses that you might carry out in order to interpret these data, and I'll do that in a separate video.